So in this video I'm going to be showing you how to write the electron configuration of ions. So let's just start with this example right here. We're going to be writing the electron configuration of magnesium with a 2 plus charge. So we're just going to go ahead and begin. So when you have 2 plus, when you have a plus charge, that means you've lost uh, electrons from its initial ground state. So magnesium's initial ground state lost 2 electrons. And then when you have a negative, that negative means it gained a certain amount of electrons. So let's start from magnesium. Magnesium has an atomic number of 12. So using this diagram, we start with the 1s, move this way, and keep moving downwards. So if it has an atomic number of 12, let's just go ahead and begin with writing the electron configuration of magnesium in its ground state. So we start with 1s squared, 2s squared, 2p6. So that's 10 electrons so far, 2 more to go to reach the ground state. And then that would be 3s squared. So so these are the core electrons, and then these are the valence electrons. The core electrons is the electron configuration of the last noble gas before Mg. And if you look at the periodic table, that would be neon. But anyway, so we want to focus on the valence electrons. If we have a 2 plus charge, we're going to be losing 2 electrons. So we're going to be losing 2 electrons from the valence electron region. So 2 electrons we're going to lose 2 electrons. So then the electron configuration would just be equal to this. And then let's move on to sulfur with a -3 charge. So let's begin writing the ground state for sulfur. And sulfur has an atomic number of 16. So let's just begin all the way up to 16 electrons. 1s squared, 2s squared, 2p6, and then 3s squared. So that is 12. And then after 3s, there's 3p, 3p4. So this is the ground state. Okay, and these are the valence electrons. So we're going to be subtracting 3 electrons. Oh no. So if we have a -3 charge, that means you're going to be gaining electrons. So you're going to gain 3 more electrons. So what comes after 3p4 is 3p5. So you're going to add 3 more to this, but it has a maximum of 6 electrons. So you add 2 here, you filled it up to 6. So this becomes 6. And then we have 1 more electron to go. So we're going to have to add the next one that comes after the 3p, which is 4s. So then 4s and just 1 electron. And so we've added 3 more electrons to the sulfur ground state. And that's it.